we looked at this tradition of saying that, well, only get worried if there's over 10 micrograms per deciliter of lead in the blood. And we found there was no level of lead in the blood that was completely without action, and we lowered the state level of concern from 10 to 5.
Because where you have silicofluorides, then the whole scale has to be changed because it boosts it. How much does it boost?
Right.
That's
right.
I know you were just giving us the numbers, Professor, but give us those numbers again. Let's say you've got a Caucasian versus a Negroid, in the same city with a set amount, and then give us the differences there.
Well, if you take the white kids who have both silicofluoride and lead, they get up to about 3.5 from 2 and 2/3 or something like that. The black kids, it goes up from 5.5 to 8, so that blacks are just much more vulnerable. Partly this is poverty, and it's calcium in particular, but and lots of other things. The chemistry of the body is.
Well, are there studies on that? So you're saying it's the diets of the blacks, or is it on average the metabolic difference?
When I do these studies, I'm just doing population studies to find out where it's bad.
But certainly you've had other scientists contact you that have an idea why it's so much more worse for blacks.
When we take the best evidence we've got and look at the difference between poor kids and kids who have average or above average income.
So it's a socioeconomic.
The poor kids, whether they're white or black, whether they're exposed to silicofluorides or not, it's always the poor kids who are most vulnerable to lead. And those vulnerabilities are much worse for blacks, and for everybody, they're much worse with the silicofluoride.
Well, here's an example. There's more diabetes in, quote, Hispanics that have the, Native American bloodline, and then certainly, the cliche is true that, quote, natives can't drink as much whiskey as, say, a Northern European who's had in their development, generationally more drinking. And, of course, that gets into, development and species. But I understand it's too many disciplines here, and you're a scientist, or a professor who likes to look at the science and just go with what you have. So you're saying it's not a genetic difference, or you don't know, between blacks and whites.
Well, actually, the point is we think about genes versus environment. The phrase genes versus environment is like saying, when you write an answer in long division, do you use the even numbers only when you write the answer, or the odd numbers only? You're going to say, Masters, you idiot, I use both even and odd numbers. And I have to say, oh, you can use both even and odd ones. The point is that everything in life involves what are called interactions between the environment.
And that's the problem with most professors and academics and scientists, is they do narrowly only look at one little area instead of that integration of the info.
That's what I'm trying to do with my last years of research, is to try and show how once you look at the integration, sometimes you find that there's one thing that's easy to change. The message I want your listeners to hear is simple. This stuff in the water has never been tested for safety. Turn it off. And make sure it isn't put back in the water until it's tested and proven to be safe by utterly independent people. And I don't mean the bureaucrats and government agencies, because they like to cover up mistakes. As I keep on asking people, when was the last time you heard of a bureaucrat who admitted his pants were around his ankles?
Well, why is it that it's known that these fluoride compounds that resemble Prozac are being put in the water, and it just accidentally does all of this? And then the original studies I saw in Pulitzer Prize-winning books from World War II is the Soviets and Germans believed different fluoride compounds had a calming effect, but your studies and real peer-reviewed studies show that actually it binds heavy metals and toxins that are associated with violent behavior because of suppression of
But let me ask you a question, because chemical compounds that differ, and when they differ, they have different effects. It's like my asking the question when I'm talking to students, tell me, if you drink scotch, bourbon, and vodka in the same night, is that different than just drinking one scotch?
Yes.
I never know a student who didn't admit that, mixing scotch, bourbon, and vodka was a very bad idea. I tried it once. My parents had a cocktail party when I was just going into my sophomore year of high school. They went out after the cocktail party, left a lot of glasses around. I decided to try them all at one night. Oh, boy. You should.
No, I did.
Morning? Boy.
I did the exact same thing a few times, yeah.
I didn't dare tell my mother what happened, but I thought I'd roll my head down the sidewalk to high school. But don't mix your drinks. And in the same way, when we mix chemicals, we have effects that we don't have one at a time. This is important because basically the government regulates, the EPA, one thing at a time. And there's another thing, which is just in the paper today about, I think it's perchlorate. The EPA has found a compound that seems to be really dangerous, and they wanted to have some rules on it, and the White House intervened and changed the document to take some of the stuff out.
That's right. Now the White House is practicing medicine, science. They just decide on a whole host of issues. We're going to skip this break with our guest, so we have a full 10 minutes left with him. Got to go to Infowars.com to hear this part. For the AM and FM stations, we'll be back in just a few minutes. Roger D. Masters, research professor at Dartmouth College, is our guest. Okay, I'm going to skip this break and talk to him. Look, bottom line, I want to explain to the listeners out there, and this is a fact, that we're told it's just fluoridation. And they can argue about that and then argue about what type of fluoride. Calcium, stannous, sodium. But it's mainly, quote, sodium they claim they put in the water. But when you really look at it, it's the same thing I see with DU. They got a toxic waste, got to get rid of it. They just put it in weapon systems and spray it around everywhere. Or they've got to get rid of all the heavy metals and stuff that are left over from aluminum plants, and also the manufacture of different chemicals and the breakdown of petrochemicals making gasoline, and they just put that into lawn fertilizer and say, well, it doesn't get in our crops. Don't put it on crops you eat, but put it on your yard, and it's lead and arsenic and all these toxins, and your dog lays in it and its hair falls out, but it still runs right into your aquifer, so you drink it. So, I mean, what I'm really interested in, Professor, is this practice of claiming a dangerous, expensive, toxic waste that for the strategic reasons in the economy they want to delist as a toxic waste, and then they use things as a cover to put it into, and that's what I see as the story of chemicals they were using, during the atomic bomb production. Any comments on that front?
For sure. The point is that if you think of humans, say 200,000 years ago, if you had some junk, I suppose you might throw it in the water and say, well, it'll float down the river and be gone. But we now have a highly technical society. They thought just throwing this in the water supply, it would disappear and it would be gone, but it turned out to be dangerous. And let me give a couple of other statistics. Where this is in the water, there's higher rate of cocaine use. Now, we measured that by the arrests, the proportion of people who are, when you arrest violent criminals, who test positive for cocaine. Where you can go from 2 people who are violent with 2 out of 1,000 criminals testing positive for cocaine, where there's no silicofluoride, and you go up by a couple where there's silicofluoride, and you go up by even a little bit more if there's both silicofluoride and lead. So what I'm trying to get to is that we've got to put the dots together and be aware that when you have dangerous things, don't use them until you've tested them for safety. We think of that, obviously, if somebody starts selling a pill to cure a head cold, but why is it any different for putting something in the water? You can brush your teeth, for goodness sakes.
Yeah.
That is, the scientific community hasn't studied this. And one thing to remember is Einstein's advice about working in science. He said that you had to be intelligent, very, very stubborn. A chemical engineer is intelligent. I'm just very stubborn. But the critical thing here is that when you have a new idea, what Einstein pointed out is, at first you're completely ignored. Nobody pays attention to you. We've been working on this for over 10 years, and at first absolutely nobody paid attention. Then you're attacked. Oh, this is junk science, this is foolish. And then ultimately, everybody's going to agree it's true. That's what Einstein had with relativity. And I think once people begin to ask the question, have you tested this stuff for safety? What's the evidence? My website, http, colon, // www.dartmouth.edu. Dartmouth is DARTMOUTH, college, .edu. / that little tilde.
rmasters / PINFO.htm. We're going back to the full audience. Here we go.